Okay, welcome everyone. Thanks for coming. This is the week 5 webinar of the class. So, we're getting there. We're deep into it. And I always like to tell you the plan. So what we're going to do is, as always, I'll answer any questions that you might have. I always have one eye on the chat box, and one eye on the lecture notes and stuff. And so I'm always happy to answer questions. So then we'll talk about sampling distributions. So that becomes really important. In the first week, we talked about how to, make a good sample. So now we're going to say, well, what can we look at all the different samples that could be done that are unbiased, it turns out, and what can we look at? So then once we do that, we'll talk about unbiased and biased estimators. So it turns out if you take a sample, there's some statistics that are pretty good for saying, all right, I got a good guess because now I know this statistic. I got a good guess what the population parameter is. So we'll talk about that. Then comes a huge important theorem. And we break it up into 3 pieces. The first is a central limit theorem for means. Okay, so it turns out that is going to help us understand how good our sample is and what our sample tells us about the population. Okay, and we're going to spend weeks and weeks and weeks doing that. And just about everything we do from now on is going to be using the central limit theorem. So it is by far the most important theorem of all statistics. So we'll talk about the central limit theorem with means. We'll talk about the central limit theorem when we have proportions, so the yes/no survey question. And then we'll also look at the central limit theorem for sums. If instead of looking at the average of something, you want the total, then there's a central limit for that also. And they're each different. They're very important. And it's easy to get confused which does which. And so I'll be stressing it, but you definitely want to practice and get that. So I want to give you a kind of a big heads up, and that is there's something really important that is due on Sunday. What's due on Sunday? Yeah, project 1. Okay. So project 1 is due on Sunday, and it is 10% of your grade. So it is important that that you do well on it. And just let you know, having project partners is, pretty much mandatory. It's pretty almost impossible to pass if you don't have a partner. So if you think you can do it alone, think again. Plead right now. You can put in the chat box if you don't have a partner to get a partner, or if you can, if there's only 2 of you, please accept a new partner for your group so that everyone can do well and you can help each other out because that's really important. Okay, so hopefully you all understand that. Okay, and look at the Project 1 discussion board to see if anyone's looking for partners. You can post, hey, we can still take one, or hey, I'm looking for one. So that's really important. So that is also important. The other important thing is the draft. I strongly recommend sending me your draft of your project. And that has to be done, recommend today or tomorrow. If at any time after 8 a.m. on Thursday, I don't look at it. So that's a promise. I will not look at it after 8 a.m. on Thursday because one thing it takes me time to do. So that's important and then I'll give you feedback if you do send it to me on time and I do it as a first come in, first read basis. So the first one that gets sent to me, I read. I've already read a few of them because they were sent early. And it gets faster if you send it early. So that's just a note on and then after 8 a.m. on Thursday, I'll just email you back saying, nope, go have a tutor help because that's all I can do. You can always post on the project discussion board and I'll do my best to answer on those too. I may be gone most of the weekend. I haven't decided yet, but I might be backpacking, so I'll be off grid on from Saturday afternoon to Sunday afternoon. Just let you know that I may be completely off grid for a 24-hour period or so. but it's on the weekend and, we all have lives. So I like to do fun stuff too sometimes. Where to? I'm just going to walk from my house and probably go to High Meadows if that's, so if you want to go there and find me, good luck. It's hard to find me though, because it's a big area and my tent will be somewhere, in the forest. Just let you know that. So good luck trying to find me if I am backpacking, but I haven't decided exactly where I'm going, but I might be going there. Um, so anyway, that's just a note. So, you know, I do have a life, but but that's just a day. But I just want to let you know that if you wait till the last minute to ask questions, I may be backpacking. So it's better to be getting help now and definitely getting your draft in. Okay. So that is the main thing. We're an odd week, so there's no exam. That's one of the reasons why the project is due this week, is I try not to have everything due at once. So so the projects are due on odd weeks. For project one and project two are both. Project two will be due on Sunday, week 11. So just a note in terms of how it goes. Okay, so any questions before I jump into chapter 7, which is essential limit theorem? I mentioned a group project that we needed to include our data and images into our paper. I can't seem to get a clear picture of the histogram. Okay, so the best way to get a clear picture of your histogram, be on your computer. Your computer better show you a histogram, and just hit screen capture. Does that make sense? If you just take a screenshot and post a screenshot on your project. Okay, and with screenshots, you can even actually make it a little, rectangle of that. Does that make sense? So if copy and paste doesn't work, go for the screenshot. Yeah, and all computers can do screenshots. If you don't know how to do it, again, every computer is a little different. Just go to Google and ask, how do I do a screenshot of a piece of my screen on my, and then you hit save and then you pop it into your project. So I think that's the easiest way. Okay. Sometimes you can copy and paste, but if you can't figure out how to copy and paste right, then screenshot is the way to go. Okay. Other questions? Good question. Really good question. Yeah, snipping tool, that's a screenshot, by the way. Yep, snipping tool. Again, that's why I didn't want to give all the names because I don't think Macs have snipping tools. I think that's only PCs. So the general word is screenshot. But snipping tools, exactly, that's what I use because I use a PC. Yeah, for a Mac, I'm not a Mac user, so they probably have something like it, but I don't know. But all computers have screenshots, screen captures. So that's for sure. Okay, hopefully that makes sense. Okay. All right. I do want to mention another thing about today. Today, the good news is from today on, pretty much, it is so easy to find relevant statistical information in whatever we're doing. So today's stuff is going to be relevant, and you might even, be able to make thousands of dollars based on what you learned today. Just let you know that. And because what I explained makes a big difference for finances. Okay, and I'm also going to show you a little political stuff too. Okay, so let's go ahead and I have a question, something for you to do. I want you to go online and look up the age of 3 baseball players and find the mean and standard deviation of their ages. Okay, and by the way, if you just have your favorite baseball player and you say how old is, you type that in the Google line, it'll tell you immediately. You could also, but that's the easiest way, is grab 3 baseball players, ask the computer how old they are, and it'll tell you. And then if you don't know how to find the standard deviation and mean, you can just go to the calculator. And if you go to one variable statistics calculator, if your ages were, say, I don't know, 26, comma 31, comma 22, I'm just making up some ages. You hit sample standard deviation because it's a sample, and you calculate. There's mean 26.33, etc. and the standard deviation is 4.5092. Okay, so it's really easy to find it, but I want you to do that. And then once you've done it, post the mean and standard deviation in the in your chat. So I'll give you a minute to do that. If you're watching on YouTube, it's a good practice to, make sure you know how to find mean and standard deviation and also how to look up data. Okay. And if you don't know any baseball players, just ask the computer to give you names of 3 baseball players and their ages. That'll do it too. And maybe from your favorite, city or something, or the closest to your city. If you live in Tahoe, we don't have a baseball team, and I mean Major League Baseball players, not some, little kid baseball team. So some now, Major League Baseball player. So pop in the chat box and give you a minute or two, but it shouldn't take too long. Pretty easy to just ask the computer and then type it in the calculator. And if you don't have it right now with you, I can give you. Okay, so what we have is we have an X bar is 29. We have a standard deviation of 5.1962. That's the first one. And then we have a mean of 32.67 and a standard deviation of net. Standard deviations can't be negative, so hopefully you mean 2.05. Standard deviations are always positive numbers because in the formula there's a square, a bunch of sums of squares and a square root. I don't get into the formula much in this class, but it can't be negative. So hopefully you meant that. Okay, there's a lot of you here, so hopefully you're all doing it because I think it's important to know how to do this stuff. This is grabbing, you're grabbing a sample. Grabbing a sample, in this case of sample size 3, which is a tiny sample, but again, we only have so much time. Let's hear some more. Pop it in the chat box. Shouldn't take too long. Got a couple of you. Because there's 12 of you here, so. Um, which calculator? So I popped it in the chat box if that helps. It's the one variable statistics calculator. You can see on the screen, it's this guy. And if you want to see from the beginning, it's this number 2, one variable statistics calculator. Okay, so don't forget to put commas in between the numbers. Let's see, we have 32 points. We got that one. We have, it's not working. Should be working on the calculator. If you go to the one variable stats calculator, you're just putting in 3 numbers separated by commas and hitting and clicking on sample standard deviation and click calculate. Yeah, this is this is a sample. We're not doing there's no way you can be able to do the population of all major league players. by looking them up one at a time. That would take way too long, which is kind of real life. You almost can never get everything. Either it's impossible or it takes too long. So let's see. Hopefully you put some in. Okay, I see a standard deviation. The mean also, I need that. I see a 6.245 for standard deviation, but we also need a mean. There we go, 35 and 6.245. All right. Now, I don't want to wait forever. Here we go. Mean of 28. And the standard deviation is 3.6056. Okay. That's as many as we're going to do just because I don't want to spend all the time on this. So notice each of you looked up at different three players and you got a different mean and you got a different standard deviation. Okay. So if you take a sample, you're not going to necessarily always get the same thing, even from the same population, if you take a sample. Okay. But what you can do is now we can look at all the X bars. We have 29, 3.67, 35, 28. Okay. And by the way, you could do this all day long and get in different groups of three, and you'd have all of these sample means. Okay. Now that means we have a whole list of numbers. Each number is a sample mean with sample size 3. When you have a list of numbers, you can do things and say, okay, what is the average of all possible sample means? What is the standard deviation of all possible sample means? Does that make sense? You can draw a histogram and you can say, what is the shape of the distribution of all possible sample means? Is that clear? Okay, so that's really important. Now, it turns out the population mean, I went online earlier today, and the population mean of ages of Major League Baseball players is 29 years old. And the standard deviation of ages of Major League Baseball players is 2.3 years. Okay, I actually thought it was going to be bigger, but it's not. Okay, I was surprised. At least that's what I found online. Okay, so notice, and this is really important, this first 29, for example, or let's say this 32.67, that's an X bar. That's a sample mean. This 29 is a mu, which is a population mean. Similarly, this 2.05 is a sample standard deviation, and this 2.3 is a population standard deviation. Any questions on that? Okay, so here's a big definition that's going to be important. And that is the distribution of all sample means with the same sample size is called the sampling distribution of the sample means. Notice the ing in sampling. It's not the sample distribution. It's the sampling distribution because it's the distribution if you're into sampling. So you're looking at all the different samples that could be taken. Now, we only took, at least I have here 4, but there's actually thousands and thousands of different samples of size 3 of Major League Baseball players. And if you look at all the different possible ones, you can look at the distribution of all of them, and that's called the sampling distribution. Any questions on this big definition? Okay, when you have a bunch of numbers, as I mentioned, you can take the mean of those numbers. You can take the standard deviation of those numbers. Okay, those numbers are X bars, but we're taking the mean of all the possible numbers. So we're looking at a population mean of all the sample means. So what we use for notation is mu sub x bar, because mu means population mean, and x bar means sample mean. So the population mean of all possible sample means, okay, is mu sub x bar. Another way of saying is the population mean of the sampling distribution is mu sub x bar if the sampling distribution is a distribution of quantitative numbers. Similarly, you could do the same thing with the standard deviation. The population standard deviation of all possible sample means, that's going to be a sigma because it's population standard deviation, and it's of sample means, so that's sigma sub x bar. And what a lot of people use for this, whether it's means or proportions, because we can get into proportions a little bit, is the word standard error. So if you're asked to find the standard error, that means you need sigma sub x bar. Any questions about these big definitions and these symbols? The symbols are a little confusing. Just let you know if like for exam where you have to type it and you don't have a lot of time, you can type it as SIGMA, and then you go, and you could do sub, and then XBAR, and I'll accept that. For your project, for project 2, for example, you'll need to do the notation because then you have lots of time. Okay, but for exams, it's okay to not get into the details of how to type that, because typing actually, even though I've done it, that doesn't mean it's easy. Typing sometimes is hard. Okay, so do you have a calculator for these? So the key is be patient, and I'm about to give you the major theorem. Okay, but we need a little bit more. Okay, by the way, this is what I just said. So the sampling distribution is for a statistic of samples of size n is the distribution of all possible sample statistics for samples of size n. Okay, so sometimes it might be all possible sample means. Others, it might be all possible sample proportions. Might be interested in all possible sample sums. Okay, or maybe even sample standard deviations, but we're not going to do that in this class. The other 3 we're going to do. So whatever you have, the distribution of all possible samples, they have the same samples. They all have to have the same sample size. That's called the sampling distribution. Okay. So again, the calculator will show you in a little bit, but not yet. Okay, now a statistic is called an unbiased estimator for a parameter if the mean of the sampling distribution for that statistic is equal to the parameter. Okay, so it turns out the sample mean is an unbiased estimator for the population mean. Are these formulas like, do you multiply them together? We'll get to that later. You got to wait till the central limit theorem. We'll get there, I promise you. So patience, please. Okay, we do have another hour of this webinar, and that's what we're doing today. So trust me on this one. But I want to get into just the ideas first, and then we'll get into the big things. Okay, so first thing, the sample mean of is an unbiased estimator for the population mean. So the good news is if you know the population mean, then the population mean of all possible sample means actually turns out to be the same as the population mean in general. So you don't even need anything other than the regular calculator, we're doing. Okay, actually, we don't even use a calculator because you're just kind of either given it or you're guessing, it turns out. Okay. So that is an unbiased estimator. So in other words, if you take, the mean of 3 baseball players and you found out it was 26 years old, that's your best guess for the mean of all baseball players. Do you see? It's not biased. On the other hand, the sample range is a biased estimator for the population range. Okay, let me explain why. That one's an easy one to understand. Okay, I'll give you an example. Let's suppose you wanted to do a sample, and let's say you're going to do the height of all people on Earth. Okay, you can imagine there is a population range of the height of all people on Earth, right? There is one. If you did a sample of, say, size 10, that means you randomly grabbed 10 people from Earth and you looked at the range, which would be the tallest person's height minus the shortest person's height of those 10 people. Do you think that's a good guess for the range for all people on Earth for their height? What do you think? Yeah, it's a terrible guess. If you just randomly pick 10 people, you know, you might get a range of height of, I don't know, 14 inches or something, or maybe even 25 inches or something like that. But if you look at all people on Earth, how tall do you think the shortest person on Earth is right now? What's your guess? 4 foot something? Okay, you have not been to a delivery ward in a hospital. We're talking all people. That includes people that have just been born. Does that make sense? Yeah. So we're talking maybe 8 inches or something. There could be that little tiny, tiny, tiny baby that was born and born way too small. Okay. How tall do you think the tallest person on Earth is? Okay. That's going to be like, 7'8" or 7'10" or something like that. Okay. Okay. More than 7.5 feet, by the way, a little more. I actually had a student who was 7'7". Yeah, 8.11. I'll believe that. Okay. And if you look at the range, that would be between those, few inches and this 8 foot tall person. If you randomly grab 10 people, you're not going to get that range. Pretty much almost never. Does that make sense? So for the range of the sample is a terrible estimate for the range of the population. Do you see how that works? So it's very important. It's a very biased estimator for the range. It turns out the sample proportion is an unbiased estimator for the population proportion. If you randomly asked, 20 people a question, yes or no, then that's going to be your best guess for the population. It won't be exactly the same as population, but it would be your best guess based on that information. Because if you look at all possible 10 people's answers, the average of all the proportions would be the same as the proportion of everyone's answer. The mean proportion. Does that make sense? Any questions on that? Okay, now here comes the big theorem. This is the central limit theorem for means. There's going to be 3 because we're going to start with means. Okay, and here it is. A sampling distribution for sample means from samples of size n has, first, mu sub x bar equals mu. That says that the sample mean is an unbiased estimator for the population mean. Any questions on that? Okay, that's a really easy one. Now comes the harder one. And this is one you would never just guess randomly, but it's true. That is sigma sub x bar, the standard deviation of all possible sample means, is equal to the population standard deviation divided by the square root of the sample size. Okay, this is really important because what that tells you is that if you have a large sample size, like size 100, then the sampling distribution standard deviation will be 1/10 the size of the population standard deviation because the square root of 100 is 10. Any questions on this idea? Okay, now remember, the standard deviation tells you how likely you are to be far from the mean, or how far do you think you might be from the mean. It's an average distance from the mean. So if the standard deviation is really small, then you're very likely to be close to the mean. So if you have a sample size of 100, then you look at the mean of those 100, it's very likely to be close to the population mean, which means you have a very good estimate. If you have a sample size 4, yeah, you divide sigma by the square root of 4, which is just divided by 2, and that reduces a little, but not much. Does that make sense? Okay, now here comes the next one, and this is really important. And this is for means, this is not for proportions. So make sure you note that. If the population's distribution is normal, okay, and the or is the most important part. If the sample size is large, in our class, the definition of large is greater than 30. Where have you heard the greater than 30 before? Where have you heard where you want a sample size greater than 30? Hopefully you all know this. Where have you heard it in our class? Yeah, the project. Okay, that was not a random number. Okay, you have to have more than 30 in your sample. That's because if you want to use the central limit theorem, you need to have greater than 30. But if you have 30 or less, then you don't have a very good sample, it turns out, because then you don't know what the distribution is. But if you're greater than 30, then the distribution is approximately normal. In our class, we're going to keep it as approximately normal, and I'm going to give you all the details. If you want to learn all the details, you need to take more advanced statistics. Okay, but that's good enough for us. Okay, because it's approximately normal, then we can compute probabilities. Because if you know the distribution, you know the mean, and you know the mean and the standard deviation, mu and sigma over square root of n, you know that it's approximately normal. Then you can use the normal distribution calculator and come up with any probability you want or percentiles. Or does that make sense? Any questions on this? All right, you ready for an example that I strongly recommend you really pay attention to it? And this is an example where you should understand it not just till the end of June when the class is over, but for the rest of your lives. Because this could mean a big difference in how much money you end up having in your life. Just let you know that. So this is something that I strongly recommend you getting. Okay, so I'm going to give you some ideas. Okay, let's suppose you have $10,000. Okay. Okay, and you have to decide what to do with the $10,000. So one choice is you can put it in the bank. Hopefully you all know that you're allowed to put money in the bank. Okay. One of the things we want to say is, what's the probability you're going to lose money after 1 year? Okay. By the way, if you put money in the bank, some bank like Wells Fargo or Bank of America or US Bank or one of those banks, what's the probability you're going to end up losing money? And there's not really a statistics question. This should be obvious. Okay. Basic probability. Should I tell you? 0. You put the money in the bank, a year later, they'll let you take it out. Okay. Even if they go out of business, by the way, that's part of the American law is that banks are federally insured. So even if they go bankrupt, you still get your money back. You may not know that, but that's true. Any questions on that idea? Okay, that was easy. Okay, now the mean interest, I looked this up this morning, is 0.4%. That's kind of the average interest of banks in America right now. Okay, today. Okay, it does go up and down, but today it's four tenths of 1%. Tiny, tiny amount of interest, right? Do you think this is the best way to invest your money if you have $10,000? What do y'all think? Okay. So the answer is it depends. If you want to make sure you're not going to lose money, this is a great way because you have no chance of losing money. Does that make sense? But if you lose a little money and it doesn't destroy your whole life, there's different ways. So, any thought of another way? What you could do with your $10,000? And there's a lot of things, by the way, but I'm going to do examples of some. Okay, so one is invest in stock. Okay, so here's the idea. Let's suppose you put your $10,000 into a randomly selected stock. Okay, and over several years, by the way, the mean is 9%, and the standard deviation is 20%. Okay. And you probably know this stocks go up and down a lot, and that's why the standard deviation is big. Is that clear? Okay. Let's assume that the stock returns are normally distributed. Okay. It's probably wrong to assume that, but let's just assume that. What is the probability you're going to end up losing money now? Which means the probability that, X is less than zero. How do we find that out? Any ideas? All right, you're not telling me, so let me tell you. You go to the calculator. We assume that we had a normal distribution, so I can get a normal probability. Okay. We want to see what is the probability that we lose money. So that's less than zero, right? If the amount of money you gain is less than zero, you've lost money. Is that clear? It's not a trick question. The mean was 9, and the standard deviation was 20. And I calculate. And there is, I'm going to round it to the maybe nearest two decimal places, 33% chance. All right. Well, if it's painful to lose money, then maybe this is a bad idea. If you got a 1 in 3 chance of losing money, that may not be the best. Any questions on that? What is another idea besides the bank or the investing in a stock? Any idea what else you could do with your $10,000? And there's different ideas, but there's kind of one. You can gamble, but it turns out your mean is going to be negative, and that's a really bad idea. And by the way, if you're in college, for example, and you're sad or mad that your mean is negative, it's my fault. They hired me. They hired me to make sure that it was negative for the expected value for I can't tell you all the details because I signed a contract. Can't even tell you which casino. But they hired me to help change their rules to make the expected value negative. The house did not always win in the old days because there were card counters. I was one of them, and I made a lot of money. But now you can't. Just let you know that. Okay. So don't even go there. Okay. So let me show you another way. And that is instead of one stock, you diversify. Does that make sense? And let's suppose now you put $10,000 into the Dow Jones Index Fund, which is 30 stocks. I know it's not perfect, but it's close enough to 31 that we'll go with it. Okay, in our class, usually we want more than 30 though. But Dow Jones is 30. Now, what's the probability of losing money? Okay. Now, we're going to have to make an assumption that the Dow Jones is a representative sample and that all stocks are independent of each other. That's not perfect. Um, the details are a little too hard for this class for me to explain, but I will tell you, I have gotten into this and I make a lot of money in investments. Okay, it really does work. So now we can take this and look at this. We have a mu of 9, a sigma of 20, n is 30. Does that make sense? So now what we can do is we can use the central limit theorem. The mean of the sampling distribution, because now we're looking at 30 stocks, not one stock. So now we're looking at the average of 30 kind of randomly selected stocks. And that is going to have a mu sub x bar equals mu. So that tells me that our mean is 9, and we have a normal distribution. I'm going to pretend, maybe I can pretend it's 31 instead of 30, but it's close enough. Okay, the mean was 9. The standard deviation is sigma over the square root of n. So sigma was 20. N is 30. So we take 20 divided by the square root of 30. Okay, and again, you can always stick that in a calculator. Is what I did. And I got 3.6514837717. So notice our standard deviation went way down. So now to calculate the probability, it's going to be the same idea, but our standard deviation is different. It's now this 3.6514837717. I'm going to leave the probability blank. And now I'm going to hit calculate. I still want less than 0. See what that probability is. And what do you notice? Okay, if you look at it, this is a very small probability. It's not even just a little less. It's a lot less of a chance. It's not 0, but it's 0.00685, maybe 0.0069 if you round. So that probability is 0.0069. Any questions on that? Any questions? So if what they call this, and you've probably heard this word before, but you probably haven't thought about it in terms of statistics, you call this a diversified investment. Have you heard that word before? Okay, if you haven't heard it, that's okay. You've heard it now. What that means is that you don't invest all the same stuff, like one stock or one industry. You invest in, this thing over here, and maybe something in food, something in technology. So for example, for me, I have some Apple stock, not food, by the way, the company Apple. I have Home Depot I bought recently. I have an India fund and invest money in India because that's real diversified, where you want to buy things that are very different from each other. And that way you really can say that the stocks are at least pretty independent of each other, especially it turns out over many years. One year, not so much, but over many years, that is not such a bad conclusion. And then you get a much higher rate of return than if you throw it in the bank. Does that make sense? So it's a much better idea to do a diversified investment in the market than it is to just throw it in the bank, especially like for your retirement if you're in your 20s right now. Because in the long term, you're fine. Does that make sense? Because of the central limit there. And this probability of losing money is so small. So how do you know a stock is a good investment? That's a long story. You do a lot of research. Now, if you don't want to do a lot of research, you do an index fund. and then it's not a stock anymore. It's many stocks. Do you see how that works? S&P 500 is even more. That's a 400 different stocks. I mean, 500 different stocks. Do you see how that works? Individual stocks, you have a higher standard deviation. There's some good things about that too, but it's more dangerous. Any questions on this example? Okay, then the next question is, suppose you want your standard error to be equal to 2. How big a sample size do you need? So notice our standard error was 3.65. You want it to be less. You want it to be 2. So 30 wasn't a big enough sample size. We need a bigger number than 30 to be able to get a smaller standard deviation. Does that make sense? So what we do is we go to the formula. Standard error is 20, is our standard deviation over the square root of n. Our standard deviation is 20 for stock market over root n. We want that to be 2. It turns out that it's a little easier to understand if you call it 2 divided by 1. Hopefully y'all know 2 divided by 1 is 2. Because then we can cross multiply. And you could say 20 times 1, which is 20, equals 2 times root n. So 20 equals 2 times root n. Divide both sides by 2, and you get 10 equals root n. To get rid of a root, you take a square of both sides. If I take 10 squared, I get 100. And the square root and the square cancel, and you get n. So I need to have 100 different stocks that are independent of each other if I want a standard error to be equal to 2 instead of 3.65. Any questions at all on this idea? Any questions? I do want to give you a heads up. This chapter and the last chapter, don't even think about including any of this stuff in your project. Okay? Not for project 1, should not be about this chapter. Don't even think about central limit theorem. Got it? Because that's not what you're doing. But I will give you a kind of a, little heads up on the future. Any guess on what you will use this for? Besides investment in the long-term future? Yeah, project 2. So it's not time to talk about project 2 yet, but when we do, it's going to involve this. Okay, so now instead of means, remember means is when you had a data where there were numbers, and that would be like, hey, how much money did you make in the stock market? That's a number. I made 9%. I made 47%. Do you see? Those are numbers. If you have the yes/no survey question instead, then we're talking about proportions. And here is the central limit theorem for proportions. So it says the following. The first thing, and this is a little confusing, is that P is a population proportion. We don't use the Greek letter because the Greek letter for P, you all know what it is? What's the Greek letter for P? It's the one Greek letter that everyone knows. I don't see y'all jumping in. Should I tell you? Pi. And you've all seen that letter pi. And pi is confusing because you think of 3.14, etc. And that has nothing to do with what we're talking about. So instead, we don't use pi. In the old days, they did. So now we're going to use p for the population proportion, even though it's not Greek. And then for the sample proportion, we use p with a little hat on top of it. That's the sample proportion. I think I did mention that earlier in the quarter, but now you're getting again. And q is going to represent 1 minus p. So if p is, say, 0.9, q will be 0.1. Does that make sense? Okay. If you need to write p hat, you can write p hat, capital HAT, because p hat is actually is kind of a pain to type. But if you do p hat, it's not so hard. Okay, so the central limit theorem says a sampling distribution for sample proportions for samples of size n has mu sub p hat. If you remember, all the proportions are numbers, right? 70%, 72%, 75%, or 0.7, 0.71, 0.82, 0.34. Those are numbers. So you could take a mean of all those proportions. That's what this mu sub p hat is. It's a mean of all possible sample proportions of sample size n is equal to the population proportion. That's just saying it's an unbiased estimate. The standard deviation of all possible sample proportions is equal to the square root of PQ over N. Okay? Remember, P is a proportion of yes answers, Q is a proportion of no answers. Because if you take 1 minus a proportion of yeses, that's a proportion of no's. You know, if 80% of the people said yes, 20% said no. Any questions on that? Notice, and this is really important, this n is in the denominator under the square root. So we have that same feeling is that if you have a large sample size, then the standard error goes down. And it goes down by that factor of root n. So if you can increase your sample size by, 100, then you're decreasing your standard error by 10, factor of 10. Okay. And then the second one, this is the one most people have trouble with. I don't know, I don't quite understand why, because it's not hard, but for some reason everyone has trouble. And that is if NP, the predicted number, and NP, if you take the sample size times the percentage of yeses, that'll give you how many yeses you have. Okay. So if NP, the predicted number of yes answers, and NQ is the predicted number of no answers, are both larger than 5, not 30, 5, then the sampling distribution is approximately normal. Okay? It does not mean N has to be bigger than 5. It's NP and NQ have to both be bigger than 5. Okay? So I want you to type something in the chat box. And that is, I want you to type this in. Type in, I promise I will not use greater than 30 for proportions. Can you type that in? I want you to promise. And by the way, if you're watching this on YouTube, write it on paper. Okay, what I really hope is you don't go against your promise because you just promised it. The reason why I'm saying this is so many people make this mistake. So maybe that'll help you not make the mistake. Okay, so you promise now. Hopefully you're the type of person that doesn't go back on your promises. Okay, what you need to do is you need to take the sample size, multiply by your P, see if it's bigger than 5. Multiply by the Q and see if it's bigger than 5. If they're both bigger than 5, then you can say you can use the normal distribution. By the way, if they're not bigger than 5, then you pretty much have useless data. So that means you need a bigger sample size. Okay, and same thing with the sample not greater than 30, because you almost never know you have a normal distribution for means. For proportions, you can't even talk about having a normal distribution for the proportion itself, only for the sampling distribution. Any questions on this big theorem? Okay, so now what I want to do, and this is what I mentioned, is that what I love about this class, this is why I love teaching statistics, is it is so easy to find real world examples and things that matter. And hopefully, well, maybe if you're a billionaire, it matters to you anyway, but hopefully it matters, to know how to invest money so you can actually do real well. Okay, it's a good life skill. And honestly, I've done really well. I'm not a billionaire, but I make a middle wage salary, but my investments have made it so I'm higher than middle wage. Okay, so, and that's because I use statistics. So it's not just to get a degree. You can actually, have a life where you can make more money with your investments. Okay. But there's other things that you can do, and that is understand the world. So I don't know, any of you have been reading the news in the last day or two? So what did Trump say recently? In the last, I think yesterday he said it. He said a lot. I know he says a lot. Biden didn't say as much. Trump said a lot. If you like him or don't like him, he says a lot. So here's the deal. So something that he mentioned is that he wants to reopen the Alcatraz prison. Any of you been there? Ah, you were thinking about that. Okay. So he wants to reopen Alcatraz. Okay. Have you been there? Okay. Yeah, I've been there. I actually gave a tour once, which was really cool. I speak Japanese and I gave it to Japanese people. So because I was the only one that could do both. And I also, a different time, actually kayaked to it. It was really fun. So, but what I don't want to do, given what Trump wants to do, I don't want to go to Alcatraz in 3 years because to do that, that means you killed someone. I don't want to do that. I'm not a murderer, by the way. But do most Americans, okay, do the majority of Americans support reopening Alcatraz prison? So maybe I'll write majority because that's a better word. Okay. So a sample size was done. The sample size was 2,969. This was just done. I was actually amazed at like how fast they were able to do this. And it was done by YouGov, is a name of the group that did the poll. I always like to give credit to the people who did it. I didn't do the survey, but I read about it. And they found 51% of the respondents support reopening Alcatraz prison. Okay. Now, does that tell us that that the majority of all Americans support reopening Alcatraz prison? Doesn't tell us immediately because they only asked 2,969. I didn't ask me. My guess is they didn't ask any of you either, but maybe I'm wrong. um, but they have a sample. So what we want to do is if it's the highest level that isn't the majority, which is, by the way, that's exactly 50%. Majority means more than 50%. So if you're exactly 50%, then that is the lowest, that's the highest number that's not the majority. Okay, so if it was 50%, what would the probability of randomly selecting 2,969 Americans, having 51% of them support reopening Alcatraz prison? And the idea is if that is a very small probability, then we're going to say that, yeah, it may not be, I'm not 100% certain, but I'm pretty sure that the majority support opening Alcatraz prison. Does that make sense? On the other hand, if it's not that low a percent for 51%, given that it wasn't a majority, given it was exactly 50%, then you would say, well, maybe the majority don't because this is just a sample and the sample size is too small. Do you see? Maybe they don't, maybe they do. We don't know. Okay. Okay. Does that make sense? So we want to see, is there good evidence for it? And we're going to be spending pretty much the rest of the entire course on understanding what it means to say there's good evidence. So this is day one. Just let you know that. Okay. So I think so they did online telephone interviews and they asked people. So now we can say if 50%, if it was exactly 50%, so not the majority, but the highest percent of all Americans support reopening Alcatraz prison, then what is the probability that of randomly selecting 2,969 Americans, at least 51% of them support Alcatraz prison. Because if that probability is really small, then we're going to say this if 51% of all Americans support reopening, so if it's only 50%, but if the probability is really small, you're saying that then you would say that this assumption is probably wrong. And we're going to say, it's probably more than 50%. Does that make sense? And that's what statistics is all about, is to be able to make those kind of conclusions. And by the way, in 2 chapters, we're going to get into all the details of this. So this is just getting ready. Okay, so now what I'm going to do is let's go through all the pieces. So first thing, let's do NP. N was 2,969. Our P is our assumption. Our assumption is 51% support it. So our P is 50% support it. So our P is 0.5. And you don't need a calculator, hopefully, to know that half of 2,969 is bigger than 5. I hope you don't need a calculator to see that, right? And NQ is 2,969 times Q is 1 minus 0.5. Okay, which, by the way, 1 minus 0.5 happens to be 0.5, but it won't always be that because P is not always going to be 0.5. But in this case, it is. And that's also much bigger than 5. So because of that, it means that we have a sampling distribution that is approximately normal. And if it's much bigger than 5, it's very close to being normal. Does that make sense? So we can say P hat, remember this notation, this tilde means has a distribution. N stands for normal. Now the central limit theorem said mu sub P hat is P. P was 0.5. So that's where this 0.5 comes from. And then sigma sub P hat is the square root of PQ over N. And that's the square root of P was 0.5. 1 minus 0.5 just happens to be 0.5 also. N is 296. That should be 2969, I believe. Hopefully, where's the typo? Yeah, that should be 2969. And I popped that in my calculator, and I got 0.009 when I plugged it in. Any questions so far? So now we can see what the probability of being at least 51% is. And I go to the normal distribution because the central limit theorem says it's a normal distribution because NP and NQ are both bigger than 5. Okay, our mean is 0.5. The standard deviation was 0.009. I believe. Yeah. In fact, maybe I'll make it easier for you to read. 0.5. You don't have to do this, but it just makes it easier to see. And 0.009. Make the probability empty. And let's see, the probability is greater than 51%, which is 0.51. Any questions on that? And hit calculate. The probability is about 13%. Okay, just rounded to 2 decimal places, or 0.13. Any questions on finding the probability? Okay, there's a lot involved in this stuff, and it is important. And it needs the stuff that was due last week, right? The normal distribution stuff. Okay, so here's the way we can talk about it. So this is the probability that if 50% of all Americans support reopening Alcatraz prison, then if they surveyed a new group of 2,969 randomly selected Americans, then there would be a 13% chance that at least 51% of them would support reopening Alcatraz prison. By the way, is that a very small percent chance or not? What do you think? What's your feel? It's not really a complete math question, but what do you think? Is 13% really small percent? Okay. All right. It turns out that in terms of the way that the world has decided to kind of like say what a small percent is, 13% is not small. Okay. The standard percent to be small is 5% or less. So 5% is small, 3% is small, 1% is very small, and that's kind of the standard. We'll be talking about that in a couple weeks. Okay, and next week too, actually too. Okay, so if it's not that small, that means maybe we don't have a majority. Do you see that? Because it's not that unlikely that, hey, this could happen just even if there were 50%. Does that make sense? Whereas, like the probability of losing in the stock market, if you have an index fund, that was really small. Do you see? That percent chance is really small. This percent chance is not that small. Any questions on this? Just a note, since we're here and it's easy to do this, what if we wanted um, so we wanted the third quartile of the sampling distribution's mean? What do you think I would do in terms of the calculator if I wanted the third quartile? Yeah, I take the probability to be 0.75. I get rid of this number because that's what I want, but I don't want greater than, I want less than. And then I would hit calculate. So the third quartile would be 50.6% or 0.506. Any questions on that? Any questions? Okay, so I figured I should mention that because that could happen too. Okay, now comes the central limit theorem for sums. Okay, so now sometimes you're more interested in the sum. Another word for sum is total. When do you think you might be more interested in the total than the mean? Another word for mean is average, by the way. When do you think you might be interested in the sum than the mean? Can you think of an example? There are times. Don't see you all jumping in. Okay, if I don't see you say, let me give you the kind of a main one of the main examples. And that is imagine owning a business where you're selling something. You have a store, so you have a shop, people come in and buy stuff. Then yeah, you might be a little interested in how much money does each shopper spending on average. But much more important is how much total money are you going to make by the end of the day? Does that make sense? That's what you care about. Yeah, so it's much more important to say, hey, how much profit am I, how much revenue am I is coming in than how much is each person spending? Do you see the difference? So total could sometimes be much more important. So that's a reason why we care about this. Okay, so sampling distribution for sums. Just a note, and you may have seen this before, there's a Greek letter that people use for the sum, and that is this guy here. And it's a little confusing because that's a Greek letter and it's sigma, but it's not this sigma. This is capital sigma. This is lowercase sigma. Just like in English, our capital letters and our lowercase letters look really different. Capital A looks a lot different than lowercase a, doesn't it? Okay, and you can say that about a lot of our letters. The capitals and lowercase look pretty different. So just note, we're going to say mu sub sum of the x's. So sigma, capital sigma x. And that is not equal to mu, it's equal to n times mu, which would make sense because if mu is the mean of how much a person spends, and you look at 100 people, then you would not expect the average total expenditure of all 100 people to be the same as one person. Do you see? So that's why you have to multiply it by n. N is 100 in that case. Any questions on that idea? And the standard deviation of our sums, instead of the square root sigma over root n, it's sigma times root n. And you may or may not know this from algebra, but if you take sigma over root n and multiply by n, you actually get sigma times root n. So that's the reason why that works. Any questions on this? Okay, and then the good news is if the population distribution is normal or if the sample size is large, and in our case, for sums, we're talking larger than 30, then the sampling distribution for sums is also normal. Any questions on that? Same as for means. Another way of writing that is capital sigma. You put a tilde, you put a capital N, and then n mu, and then sigma times root n, because that's the mean and the standard deviation in order. Okay, so let's look at an example. All right, so I'm gonna do a specific example of a restaurant. Again, if you're the owner or the manager of a restaurant, you care about how much money is coming in by the end of the night, right? So suppose that the average customer at a restaurant spends $33.23. Okay, so it's not that an expensive restaurant, but it's not McDonald's. And the standard deviation is $9.22. If 65 customers eat at the restaurant today, what is the probability that the total revenue for the restaurant will be less than $2,000? And what is the first quartile for the total revenue for a day? So one of the hard parts about this chapter is to read the question and know which of the three types you have. Whether you have central limit theorem for means, central limit theorem for proportions, or central limit theorem for sums. Okay, and by the way, I don't know if you remember my definition of hard. So I told you it's one of the hard parts. What's my definition of hard? Okay, not all jumping in. My definition of hard is a lot of students get it wrong. Whereas easy is almost everyone gets it right. Isn't that a good definition for hard and easy? So a lot of people get it wrong, and the reason why they get it wrong is they're reading and using the wrong central limit theorem. Okay, and one of the biggies is sample size. If you have proportions, don't go 30. It's not over 30. And by the way, the number 30 is not bigger than 30. What's the smallest sample size you can have that's bigger than 30? This is really obvious. 31, okay? So that is important to know. Okay, so for this one, when we have the mean was 33.23, standard deviation was 9.22, and 65 customers, we can say capital sigma, the sum, has a normal distribution. And now it's n, which is 65, times mu, which is 33.23. comma, sigma, which is 9.22, times the square root of n, which is the square root of 65. Any questions on how I came up with that? Okay, then the next thing, and this is important that you know how to use your basic calculator, not fancy stats calculator. But 65 times 33.23 is 2,145. And 9.22 times root 65 is approximately 74.334. Okay, so it is important to know how to plug in, and that's just calculator. All right, so now we want to find out what's the probability that the total revenue will be less than 2,000. How am I going to find that out? What do I have to do? Any ideas? All right. Should be obvious. I need to go to the calculator. Yeah, there we go. Other calculator. Actually, the same calculator as what we just had. I'm going to hit refresh just to clear everything. I want the probability that it is less than. So I click less than and 2000. Any questions on that? The mean was 2,145. The standard deviation was 74.334. And I hit calculate. And there we go. 0.025549, or how about 0.0255 is 5. So there is a 0.2555 probability that the total revenue will be less than $2,000. Any questions? Did I do anything that was brutal? Okay, imagine if you didn't have a calculator. That would be really brutal. When I first taught this class, that's how it was for this stuff. It was such a hard class. Okay, I know some of you think it's such a hard class, but you could just was such a brutal class without a calculator. Okay, and not because of my rule, it was just pre-technology. No normal distribution calculators. They just didn't really exist. Okay, so now what we do is the next question is, what is the first quartile? So for the first quartile, what do I have to change? Yeah, probability is 0.25. And I want less than, and I don't know. By the way, do you agree that this calculator is not that hard to use? Yeah, I have been noticing when I read like your exam questions and when I read your discussion post questions, some of you are doing it in a brutal way without this calculator. And don't do use these calculators. If you get it wrong without this in your brutal way, I take a lot of points off, actually. I want you to use this calculator. It's a requirement. Okay. Now, for the project, you're supposed to use a spreadsheet. You have to use a spreadsheet. Okay. But this is don't get into z-scores and stuff like that to find these probabilities. That's a lot of work, and you're not going to get it right because you're going to round wrong and all kinds of things. Just use a simple calculator. Okay. I worry that people might be using AI and it uses that z-score stuff, which doesn't get it as right. So I take a lot of points off. Do not use AI to do your work. Okay, so we want less than, and we find out. And it's 2,094 and might as well go pennies, 86 cents. 2094.86. Okay. And by the way, the probability was 0.2555. Okay. Any questions on those questions? Okay. How about this one? Let me ask a question because a lot of people have trouble with these questions when they're on the homework, on the chapter questions in the exams. And that is between what? Let's make that bigger. Two values will, let's say, 80% of, oh, will there be an 80% chance of the sample mean lying between? Okay. So the idea, and this is where the picture helps. So we have a normal distribution, right? The mean was 2145. And between, if you want to say, well, in this normal distribution, I want 80%. So that means 80% is going to be in between these two numbers. What are those two numbers? Any questions on the question? Any idea how I can do that? And I'm doing this, so a lot of people have trouble. Okay, so we want to look at the middle 80%. So between what two numbers will the middle 80% lie between? Does that make sense? So it might be here to here, and that would mean 80% is in between. Okay, so you got a good first part. Not that's not the answer that you just wrote, point one and point nine, but it's actually really important. It's going to be the first step. Okay, and that is saying, well, if 80% is in the middle, then how much is on the left? 10%. Because if 80% is inside, 20% is outside, but there's a left and the right outside. So if the left and the right give you 20%, then the left gives you 10%. Does that make sense? So what I do is I say, well, if the left is 10%, that means I know the probability is 0.1. It's left, so that's a less than. And I erase the number and I click calculate. And it gives me 204974. $2,049.74. Now, if I want the right, if there's 10% here and 80% up to here, that's 90% to the left. So instead of 0.1, I do 0.9. And I'm going to erase this box. And I'm going to hit calculate. And I get $2,240.26. 224026. So we can say that the middle 80% is going to lie between 2,049 and 74 cents and $2,240 and 26 cents. Any questions on that? Okay, so it's kind of nice to be able to understand because it gives you information about what's going on. That makes sense? Okay, and you care about that. What's kind of a typical day? And that would be the range of a typical day. If you say the middle 80%, we're going to call typical. Do you see how that works? Okay. Any questions at all on this? Okay, so the secret word of this webinar is root, ROOT. Okay, first let me say the secret word a few times, make sure everyone has that, and then I'll go back. Um, so the secret word is root, and that's because if you, the central limit theorem says the standard error for means is sigma over root n. And the central limit for proportions is the square root of PQ over n, so there's a root n. Okay? And even the standard deviation for sums is going to be sigma times root n. So all three of those standard deviation formulas have a root in them. So that's why I like to give you a word that happens. But that you probably wouldn't have just randomly guessed if you were hoping to get the secret word. So that's the secret word. And then someone asked for back to the calculator for the 0.9. Any questions on it? I typed in 0.9. I erased the box and the P of X is less than, and then I hit calculate. Any questions on that? I do want to mention a couple more things, and that is about the project. It's a typical thing people have that don't do enough of in the project. Remember that you are required to have a client for your project. Okay, it can be fictitious, but you're not really having to have someone pay you, but you at least pretend you have a client. The client is your audience. Okay, the client is who you're writing this to. So every time that you have something that you can see, like a statistic or a chart, explain how the client will use that information. What decisions might the client make? Okay, it's a big problem that people forget to do. Don't just give the general definition of the standard deviation or the median. Explain what that's going to tell the client and what decisions will the client make based on that value or that chart. Does that make sense? Okay, it's kind of the most common error people make. Okay. Yeah, the client should be a specific person. Okay. And it's pretty easy to go online and look to see who's in charge of whatever. Does that make sense? And if not, then you can say, let's say it was, hey, the manager of Safeway. Then you can pretend to say, hey, the manager, you just write in your project, the manager of Safeway is, Beth Stringer. And then you talk about what Beth would want the whole project. Does that make sense? And I'm not going to look it up to make sure it's Beth Stringer for the manager of Safeway. But if it's someone at our college, then it's easy to look it up because all the employees at our colleges are online or on the website. Just let you know that. So if it's like a, counselor, you can easily find the names of all our counselors. Does that make sense? Okay. So you're asking, so both probabilities were less than? Yeah, that's because we use 0.9. So if we wanted the right-hand side and we wanted greater than, it would be 0.1, right? 10% is below, 10% is above. And if I do 0.1, notice this, if I do 0.1, This was 22.40 and 26 cents. And I do greater than, I get the same answer. Does that make sense? Because because probability being 0.1 for greater than is the same as the probability of 0.9 less than, right? If there's a 1% chance of being bigger, there's a 10% chance of being bigger, there's a 90% chance of being smaller. So that's the reason why. So you can go either way, but you have to really understand what you're doing. That's all. Other questions? Other questions? Okay, let me stop the video then, stop the recording. Thanks for watching this, and hopefully you'll make sure you have partners for the project. I know some people don't get partners. Okay, it's a disaster if you don't have partners for the project. If there's only two of you, please accept a third person if someone's asking. Okay, so that's really important. So now I'm going to stop the recording.